Howdy, howdy. Welcome to our webinar. This is week number 3, private builds. So glad you're here. We have a great crowd here. Some logistics to get out of the way. The Q&A window below. If you would, if you have any questions, go ahead and put them in the Q&A window. I'm pretty good about working in answers to those questions during the content. My commitment to you is that I won't end the webinar until all the questions are answered. Also, my assistant Rain will be providing some resources in the chat, some links in there, and you can, so make sure to pay attention to the chat. Feel free to have a conversation on the kind of a back channel, and we'll get right into the content. I know your time is really valuable, and we'll try to get you in and out, not use up the full hour. Some of the past webinars have been going about 30 to 45 minutes, and we're executing a weekly webinar series, a 7-week series on .NET DevOps for architects. And so as some of the late arrivals have gotten in, we have a tremendous crowd here. And so really excited to dig in. So let's get going. My name is Jeffrey Palermo, and I'm so glad that you're here. If you're a regular attendee, you have heard this before, but we have so many new folks tuning in that I need to level set if you haven't. If you're signing up for these webinars, then that means that you want to get more done, move faster, and produce higher quality. And you want to deliver for your team, for your company, and for your customers. So this series is .NET DevOps for Architect. It's guidance aimed at software leaders who want to enable their teams to be world-class. And I know from experience that if you map out your software delivery process and then automate it, you'll deliver more, and you and your team will absolutely love programming again. But we do have an enormous problem, a serious problem, and a problem we're going to have to solve. Most teams automate work for their own customers by producing software, but then saddle themselves with new administrative work to build, deploy, and monitor software that relieved customers of their administrative work. So there's no reason that the cobbler's kids shouldn't have shoes. And I work with teams all the time where one of the most senior, most capable developers is trapped by the task of deploying the software because he's the only one who understands the software well enough. And they take their best talent with the most experience with the software and reduce them to weeks full of administrative tasks. A deployment is a set of administrative tasks: copying files, change a config file, configure a credential, start a service, and then do it again and again and again, over and over. And we all got into software because we saw the tremendous power available. We can write code and make the computer do something that makes ours and other lives better. So then we shouldn't settle for a process that takes people with technical creativity, you, and turn them into an automaton. For you managers listening in, I want to share with you what goes on in the brain of your people who have to do these manual processes over and over. And we as humans are always in the pursuit of happiness, and whether we get fulfillment from serving others or making something new, your people aren't finding happiness in the process of manual builds or environment configuration or deployments. They want to get it done as fast as possible so that they can get back to why they got into software in the first place: to create things, to solve interesting problems, to make others' lives easier through software. And so as a result, the manual tasks are error prone. And the more your staff endures tasks that don't bring happiness and satisfaction, the more they become open to considering maybe other employers that might be able to provide more work that does bring satisfaction. So whether you're an individual developer, you lead a team, or a manager in technology, this session is for you, and this series is for you. So last week, we had an overview of the VCS mistakes, the 3 critical elements there. But today we're progressing into private builds, okay? And I want to give you something of value and help you get automated and help you get through this content. So I don't want you to continue to be frustrated and sometimes trapped by the software that you work on. And doesn't software always seem to find a way to break upon deployment? And so let's get away from the lost weekends and surprise overtime due to the software builds and deployments going poorly. At Clear Measure, we've helped hundreds of thousands of professionals across 40 countries be better at software. And my latest book, .NET DevOps for Azure, shares the secret about how any team can have a fully automated DevOps pipeline by following a concrete 7-stage design. So here's what you need to do. First, read my book. And I am giving you an ebook copy right now, free, just for being here on this webinar. And you can send me an email or post a request in the chat and I'll get it to you. And by the way, whether you're watching it live or if you catch this recording or if a colleague forwards it to you, I'll honor that offer. And so number 2, you need to understand the 7 stages of a DevOps pipeline, which is in the book. And then 3, launch your own .NET DevOps pipeline and use our free public project as a model. And again, you'll find it in the book, and I'm also highlighting it here. So if you do this, you will have a fully automated DevOps pipeline for your application using Azure for environments, and that will enable you to move faster and with higher quality. Okay. Also wanted to highlight some specific training, hands-on immersive training for you and your team. If you're interested, you can go to bit.ly/.NET DevOps Bootcamp. That's at the end of October, at the end of this month in Austin, Texas. There are still a few seats remaining. And so get over to that. And of course, you can send me an email and ask any questions if you need to, but I will be the trainer. And this is in-person, immersive, hands-on boot camp style training. That's the only type of in-person training I have is boot camp style. Get you in it, get you working with it. You will build the pipelines yourself. You will do everything yourself. This is not just a lecture course. You are going to be doing it. And then also another resource you might be interested in, the Azure DevOps podcast. I'm the host. You can find it at www.azuredevops.show. All right, so let's get into our agenda. The 7 key elements of a DevOps environment is our webinar series. And we have already gone through the pre-code design process and the VCS structure. That is done and that is behind us, okay? And we are progressing. I introduced Onion DevOps architecture to you and the principles. And just a very, very brief review, the 3 ways, the 3 guiding principles of DevOps are flow and feedback and learning. And DevOps gives us a model to ensure that we identify all of the needed architectural elements through flow, feedback, and learning. Flow is about pushing things out. And of course, if we just stopped at flow, then we would be really good at quickly pushing things out. In fact, we'd be really good at pushing more and more defects to production. Feedback is all of the quality controls that we put at every step of our flow to make sure that we are filtering out bad things so that when a release finally gets to production, and we hope that it happens a lot, that it's really good. And learning is creating a learning loop from every one of those elements of feedback back into flow. All right, so I introduced Onion DevOps architecture, the principles here on the screen. Each concentric circle, each layer in the Onion model spins at a different speed. Each one represents a cycle, and the interior cycles must spin faster than exterior. So today, we are diving into the code layer right there in the middle. And just to ground you, if your mind thinks better at the Kanban form, then this is the overall process view, and each of these pieces of the process can be represented as a column on your Kanban board. So we are in the middle with developer and our Azure repos, Git, VCS, and that's where we are. So diving into code, some of the questions that we're looking to answer is, how do we detect and prevent defects? And how do we stay aligned with the architecture of the software? And how do I get it working too? And so let's dive into code and just blow this out. If I zoom in, I'm going to zoom into code and actually blow that into 4 interior layers, all within that code nucleus, all within that code nucleus. So the boundary to get out of the code nucleus, go back, is a pull request. But if I'm totally within that code nucleus, then I do a lot of other cycles before I get to a pull request and push the code to master. So run local, that's the middle here, is diving in, zooming in more. Run local is the work that you do while changing code and rerunning the application, hitting Control F5 or debug session, edit and continue, or edit and refresh. The private build layer is what you do to make sure that what you just changed still operates when within the whole application, and that you didn't accidentally break anything else. The branch CI layer, branch continuous integration, is a team-based continuous integration build running automatically on your feature branch, which also receives back merges from master so that you know that your changes play well with recent changes that have been accepted to the master branch. And then the branch deploy layer, that's the cycle where we deploy the product of your branch continuous integration build into a TDD environment or a full system test environment instance. And we run those full system tests. And this lets you know that what you just did will still deploy and will still start up properly, as well as pass whatever suites of full system tests that run against your fully deployed environment. So I see continuous integration builds being adopted all the time in a very thin way. And if you look at the quick starts online, click, 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 oh, look, you have continuous integration, but all you're really doing is compiling. You're compiling the code, but you don't know if it even works. Now, the adoption of continuous integration, that's very positive, but it can leave a team with a false sense of security, thinking that the practice is in place, and management thinking that the practice is in place. But then the team is frustrated because the promised increase in quality and productivity just doesn't happen. So I want you to stop being frustrated by a slow development cycle and stop spending the next sprint fixing bugs created by the previous sprint. Over this week and next, I'm going to show you how. But this week is all about the 2 inner code loops in our DevOps cycle, run local and private build, because we're focusing on private build. So now I'm going to cover the 3 essentials for a private build. Okay. So let's take them one by one. The first one, scripted and versioned. This cycle within the code layer in our DevOps onion is aimed at letting you know if it's worth even committing what you just changed in the code to Git, if it's even worth committing. A server build of any sort is kind of irrelevant here. Since this private build process, it varies over time, it must be versioned with the application. And all team members should share and use this private build script. It is a team asset. It's in source control with your application. And I'll show you an example of one later. Next, second one, the private build script has to set up its own dependencies and the application's dependencies. Let's keep this simple. Most applications use a data store of some sort. The Onion DevOps Architecture project, public project that comes with the book, uses a SQL Server database, which is very common. The database schema needs to be set up locally. What example? When back merging from master into your branch, you're going to frequently receive changes to the schema from your teammates. And running the private build script should automatically and seamlessly either update or maybe recreate your local database so that you don't have to do anything. And anytime you have to manually adjust your local development environment for your application, your productivity is going to slow to a crawl. And again, you're configuring, you're setting config values, you're recreating database. It just sucks your time. So with more developers managing more and more applications, you have to remember all the dependencies that might have a setup change. That's a lot. And doing that every time manually, it doesn't work. So the build script has to be set up, locally in version control, scripted and versioned, and has to set up your local SQL database and other dependencies. Also, your private build should be able to execute with your network totally disconnected. This is really important. You should be able to fly your computer to the moon, totally disconnected from a network, and your private build should still work. That means for some of you, you'll have to adjust your architecture so that you can simulate some of those outside systems to enable standalone execution of your application. And this is going to force you to make some architectural decisions for what dependencies your application architecturally owns and which ones are external dependencies that your application merely integrates with. All right, that's some important decisions. Okay, this third essential here, the build has to run tests. Okay, these are validations. Test-driven development gave us a great pattern for any type of validation. It was arrange, act, assert, or AAA. Now, arrange is setting up the application environment, the dependencies, the local SQL database. Act is compiling and setting up to run locally. And assert is at a minimum XUnit or NUnit tests. In the private build, we want it to be as fast as possible. So we can't run every type of test suite, but we can run unit tests along with component level integration tests. And just for those new to testing, unit tests are tests that don't cause the call stack to go out of process. They are blazing fast. Thousands can execute in seconds. We've seen 6,000 unit tests run in 40 seconds, even on slower computers. And an example of a component level integration test is a test to ensure that a SQL query or a class maybe using Entity Framework works. To do this, the process is going to have to call out to the local SQL database running on your computer. And these are slower because they call out a process, but we can still run hundreds of these in under a minute. And that's great. We want to do that. We cannot run any cross-application integration tests because we're in a local environment. Those tests can happen in a fully deployed environment. And we'll talk about that next week. So to recap, the three essentials of a private build is that it has to be scripted, has to include dependencies, and has to run tests. Okay. Now, last week we showed you an example VCS repository. Build.ps1 is our PowerShell script. That is the private build file. It's as simple as that. It is a PowerShell script, as simple as that. And to show you the structure of it, this is the structure. We have private build calling a series of functions one at a time. Now, what I don't show you is the very top of this file, which, by the way, if you go to the public project that's included in my book, you get all this code. You can pull down this file exactly. I welcome you to copy and paste and steal it and modify it for your application and use it, okay? Use it. So at the very top of this PowerShell file is something that makes this really portable for all of your applications. And that's just the top level variables. The top level variables are the things that are going to change from application to application. For example, if you have 10 different applications, you have 10 different Git repositories, this same build script can be copied into each one of them, and you can use the same structure, but just change these variables at the top. And so over the years, we've pulled out the variables that change from application to application so that we're not reinventing a private build for every application. So the project name is also the solution file without the .sln, a path to unit tests, integration tests, a path to the acceptance tests that need to get packaged up for running on a fully deployed test-driven development environment, and the path to various key projects. Also, you see where we have searching for environment variables. This is just a little flexibility that's often useful if your teammates have different named instances of SQL Server. And also this is leveraged by the continuous integration build, which wraps this and calls this script. And so we'll go into some of that next week. All right, as we go down the file, the init function and the compile function, this is what they look like. Pretty darn simple. Now, this project is .NET Core 2.2. It'll be upgraded to .NET Core 3 pretty quickly, but we're going to remove the build directory. This is where we clean up any artifacts from the past builds. We remove it, and then we make it again, and then we are executing .NET.exe with various things, okay? And we're also using the verbosity variable for the build script, so we can set it in one place, and all these different commands that we're running that all require verbosity, we just flow that through. And look at the compile function. There is a lot of things and a lot of command line switches that go into properly calling .NET.exe build. And so if you rely on Azure pipelines to just call .NET build or MS build, you're having to put all of this command line switches into a place that either is not version controlled or is version controlled in a YAML file in a form that you can't run locally, enabling a private build cycle. Okay, so just put it in PowerShell. It's super easy. Okay, this is the function to migrate your database locally, to create it locally. Now, whether you use DBUp or Roundhouse or AliSQL or Redgate SQL change automation, this is where your command line goes to run the tool and recreate your database locally from the scripts that are stored in the Git repository, okay? And this is how we run tests. Unit tests, integration tests, they're separate. So for .NET Core, this is a pattern that works really well, getting the proper test output that can be attached to Azure pipelines and making sure we accidentally don't do a duplicate NuGet restore and a duplicate compile just to run tests. And also, we want to enable code coverage. And so we have to run it with the proper command line switches. We want to run unit tests first and integration tests second, because if one of the unit tests fails, it makes no difference if we run the unit tests. And so we want to do those in sequence. Finally, we have the helper function private build, which is at the high level, which just calls these functions in order, just like regular PowerShell. We wrap it in a timer so that it outputs on the console when we run it. And that's essentially a private build script. It is super simple to put in place for yourself. If you're on .NET Framework, that's fine too. We have another example with msbuild.exe and all of the .NET Framework command lines that we can provide for you. Just get in touch with me. And so let's review the three essentials. It has to be scripted and versioned. It has to set up its own application dependencies. It has to run tests and other validations. And one thing that's overarching with all of this DevOps automation, make sure it's fast. Everything in DevOps, you want to make sure that it's fast. And this is one of the innermost cycles in our DevOps model. So we want to make sure that this private build can happen very, very quickly. So this is all within the code part of our DevOps onion. And we're going to code and run the application locally many more times than we run the private build. We're going to run the private build many, many more times than we run the continuous integration build on our branch after a git, commit, and a push. So you get the pattern. The interior layers cycle faster and have many more iterations than the cycles that surround them. And so to ground us again in the Onion DevOps architecture, we've been talking about the private build, which is inside the code core of our Onion model. A pull request and getting those changes into the master branch is in the engineering layer, where we as a team put out a new build for our stakeholders or our project managers to look at. You team testing, code reviews. As a team, you say, hey, it's time for some other people outside the team to look at it and do some manual testing. Then product management, or your Scrum stakeholders or Scrum product owner, they decide if a release candidate is ready for release to some actual customers. And then the strategy layer is where we have the released version in the hands of our customers being used by them, and we're monitoring it and we're getting feedback. We're gathering data and telemetry, And we're coming up with new ideas for changes and future capabilities, and also bug reports that need to be cycled through fast. So the next topic that we're going to tackle next week is the continuous integration part of build. Okay. So we're actually extending this a little bit because I broke out private build and continuous integration build. So we covered private build this week. We're going to cover continuous integration builds next week, which has a dependency on just the ability to have a build, regardless if it's continuous or regardless if it's actually integrating changes from multiple developers. All right. So that's next week. Tune in next week. Next steps for you, remember, either through chat or send me an email so I can send you a free copy of my book. And as you read the book, use the included Azure DevOps Services project template, that public project, use it, copy it, clone it, and literally get up and running within a day, end to end. And that application has a web application, an offline job, and a SQL database that has all these test suites set up, static code analysis. Literally, if you want to use that to jumpstart your project and just make that into your web application, go for it. I hope it helps. Also, be sure to subscribe to my podcast, the Azure DevOps Podcast. And next week, tune into the webinars. We dive into how to design your continuous integration build process, and how so many of the videos you'll find on YouTube just don't actually cover all of the things that you need to think about when putting together your continuous integration build. All right. I'm gonna with that look at the questions, and it looks like I've answered all of them in line. And just checking to see if any questions come in right at the end that I need to get in. Make sure to sign up for week 4's webinar. The link to that webinar has just been placed in the chat. You can click on that now and register. And also the links to the in-person hands-on training at the end of October. That link is in the chat as well. And Rain's also sent out a link where you can click and get the ebook quicker. And she's also put in the chat the link to Amazon where you can pre-order the print copy of the book, which will come out in about a month. So thank you so much for your attentiveness. It's my pleasure to share these important elements of enabling your DevOps environment. And until next time, keep shipping.